Hey guys, today we will be talking about all the factorial numbers having n trailing zeros, which means like we have 5 factorial. 5 factorial has one trailing zero, and that how can we calculate that we are going to talk about today. So let's begin with it. So we know that in a factorial there will be at least the power of 2 in a factorial will be always greater than the power of 5. So we don't have to worry about 2, we just have to worry about the number of the power of 5. So the number of trailing zeros will be the same as the power of 5 in the factorial. So in order to calculate the power of 5, we can start coding. So what are we going to do is, first we are going to begin with an input. We are going to take an integer input which will tell that how many trailing zeros are there in the factorial, and then we have to output that what all numbers are there. There will be five numbers only. That is just the pattern that will end with x trailing zeros. So what we are going to do is, we want that in 5 factorial there is 1 power of 5, then in 10 factorial there will be 2 powers of 5, so there will be 2 trailing zeros. So in 11 there is 11 is not a multiple of 5, so we don't care about 11 factorial, because so we can conclude that the number of trailing zeros in 10 will be the same as the number of trailing zeros in 11, and same implies to the same implies to 12, 13 and 14. And now if we go move on to 15, we see that 15 is a multiple of 5, so one more 5 will get add up, which means that there will be 3 trailing zeros in 15. But here comes an exception, like 15 will have 3 trailing zeros, then 20 will have 4 trailing zeros, but 25 will not have 5 trailing zeros, it will have 6 trailing zeros, because 25 itself is a multiple is 5 square. So it will have the total power of 5 will be 6. So there will be 6 trailing zeros. So we cannot simply apply a pattern like an AP or arithmetic, what we say arithmetic progression. So here we are going to make a while loop. So what we want is, we will make another variable. Let us make it in a new line. We will make another variable which will represent the number of trailing zeros, or we can say the power of 5 in our particular number. So also we will make another variable which will tell us that at what value will the value of n change. Like after every 5 numbers the value of n will change, definitely it will change. Now we don't know it will change by 2 or 3. Like if we move on from 124 to 125, there will 125 can be written as 5 to the power 3. So it means that it will increase by n will increase by 3, and it doesn't mean that after 125 only 625 will have the exception. Like 250 in 250 also 250 can be written as 2 into 5 to the power 3. So there will be a gap of 3 as well in 250, and the same implies to 375, then 500 and so on. So we are going to make p variable. We will declare this also as 0. So what we want is, while n is less than x, which means that the power of 5 in our p will be less than until the power of 5 that is n is less than x, we will continue to increase the value of p. So as we saw the pattern that after every 5 numbers the value of n will change. So we are going to play around with this variable. We want to see what power of 5 is p. I mean the what we say that the prime factorization of p will have 5 to the power n. So what will be the value of that? So what we will have to change the value of p. So we will have to declare another variable, because we cannot change the original value, we will have to keep it that only. So now while s percent 5 is equal to 0 and s greater than 0, now let me explain you this. So while s is a multiple of 5, we will keep on dividing s by 5 so that we can find out that what multiple how many numbers do we have to skip. Like we just talked about that 20 factorial will have 4 trailing zeros, and then 25 factorial will have 6 trailing zeros, which means that there is no number with whose factorial is will have 5 trailing zeros. So we will have to consider that also. So what we did is we just counted the power of 5 in the p, so that we can just add it to the n. And now what we can do is we can simply, now we saw that the number of trailing zeros in 10 factorial will be the same as number of trailing zeros in 11 factorial, and that will also be the same as 12 factorial, then 13 factorial and 14 factorial. No need to use the longer method that we will find the factorial of each number and we will check that how many trailing zeros are there, because that is a very wrong method. It would be a very long as well as a wrong method. So what we can do is we'll just print p, and then p plus 1, then p plus 2, then p plus 3, then p plus 4, as all of them will have the same power of 5. Here in a range function, p plus 5 will not be included, and I will increase every time by 1. Now what like now we can test it. We can put it now we just talked about that the answer should be, there should not be any output if x is equal to 5, and this is because after 20 factorial there will be 25 factorial, which will have a change in the value of power of 5, but it will increase by 2. So after 4, 6 will come, and 5 should have no power, but our program will show that. And if we replace x is equal to 5 by x is equal to 6, then also we will be shown with the same output. What we want is we know that it should show no output when x is equal to 5 or when the numbers are being skipped. So n is not equal to x. So when n is equal to x, the loop will break and we will get the output. When n will not be n will never be equal to x, then the loop will become infinite. Once n becomes greater than x, like if x is equal to 5, then n will be 4, then after that n will skip 5 and become 6, then 7, then 8, then 9, 10, then it will skip 11 also. So now it should give no output if we replace x is equal to 5. And it is giving no output. Now if we take 61, I have calculated that 61 will be skipped in such a case. You can also try to find out, but that will be a very long process. There is another method that we can use, for computers this would be a good option, but if you want to calculate, you will have to find out, like if we are given x is equal to 5, x is equal to 6, then for example our answer is we want to find the power of 5 in 10 factorial. Then what we will do is 10 divided by 5, then we will take the integral values of 10 to the power 5 upon 5 to the power 10 divided by 5 to the power n. Like we can write sigma of integral value of value of we don't have a particular function for that, so um, integral value of the our final answer. For example, our final answer was p divided by 5 to the power n, and sigma will have the least value as 1 and the maximum value as infinity, and integral value will become 0 after some time. Like um, if our p is 626, then after n will become 4, like 5 to the power 4 is 625. So after 4, when n will become 5, 5 to the power 5 will become greater than 626. So our integral function will keep on adding 0 to that. So here's what we can do in our notebooks if we really want to calculate its value instead of just looping through everything. So thank you. Please like, share, subscribe to this video.